The next section in Chapter 2 is about inverse functions. I think that you have seen inverse functions before, but I want to start at the beginning just to make sure we're all on the same page. So if we have a function, so things that we've talked about before, a little bit of review. Our functions are written as something like this. F that maps x onto 3x minus 2. Okay, so for instance, if we had like the input, so input is x's, and we input -1, 0, 2, or 1 and 2, sorry, and 2, this would be our domain because it's what we input. It's our x values. And what happens is they map, so that the reason why we say f that maps x is they map onto y values. So if we plugged in -1, we'd get -5, 0 would give us -2, 1 would give us 1, and 2 would give us 4. So this set B would be our range, and our range is always the y values. So let's think back to our definitions. For a regular function, we said that a function maps A, so that first, I guess, oval, which is our domain, onto set B, which is our range. So this is just a little bit of review from what we did before. So what happens is one of these maps to one of those. And we really just have one of each. The rule we had was it has to pass the vertical line test. So we had to say no two x values for the same y. So we couldn't have -1 mapped to -2 and 0 mapped to -2. That would mean that it is no longer a function. It is not a function anymore. Okay, so that's not the case with what we have here. What we have here is a function because everything maps. We don't have any overlap there. Okay, so what's going to be different when we talk about inverse? Inverse is denoted, so we write f, and then in the place of an exponent, we put a -1. So that's our notation for an inverse function. So let's say that we have the same function, we have the same group A as above, and we have the same group B as above. So group A was -1, 0, 1, 2, and group B was -5, -2, 1, 4. And this was still A and B. What an inverse does is it's the opposite. So instead of mapping A onto B, it maps B onto A. So then -2 would lead to 0, 1 still leads to 1, and now 4 would lead to 2 instead of the other way around. Okay, so something has to be what's called a one-to-one function to have an inverse. So that means that one domain maps to one range. That's why we say one-to-one. In this case, like up above, we had the vertical line test because we could not have like two y values mapped to the same x value, but we could have one of our x's mapped to two different y's. Now think about this. If we were going to go backwards, then backwards would lead two different things to one thing. That's not a function anymore. So that's why we have this rule for inverses. It has to be a one-to-one function. Not everything has an inverse. Only specific things have an inverse. So we have what's called the horizontal line test now. If it passes the horizontal line test, which means you draw a horizontal line and it can only touch the graph once, that's telling you that you can find an inverse. And it only has one inverse. There's only one to find. They're matching pairs. You can find the inverse if it passes the horizontal line test. All you do to find the inverse like actually when you have an equation, oh, that's not how you spell inverse. Let's try that again. You just switch x and y. And then you'll have to solve for x. So if we had to find, so let's get a function, f that maps x onto x plus 2 over 3. And we are asked to find f inverse. Ooh, that's a negative. Well, remember this can also be written with the colon thing. We can write that as f of x. F of x is the same thing as y. So what we're going to do is we're going to switch those two things. When we find f inverse, that means on the inside, instead of x being on the inside, y is on the inside. Instead of y being over here, x. So these are switched whenever we change to the inverse. Okay? So, for example, if we literally have this equation, we could rewrite this as x plus 2 over 3 equals y. To find the inverse, everywhere we see an x, we write y. So now we're going to have y plus 2 over 3. And if we see a y, we change it to an x. And then once you get to here, you have to solve for y, because all of our functions are always y equals. So the first thing, to get y by itself, right now I have a 3 on the bottom. So that means dividing by 3. So the opposite is multiplying by 3. So that will give me y plus 2 equals 3x. And then I subtract 2 from both sides, 3x minus 2. And then finally, sometimes what you'll see is they'll rewrite it with inverse notation. The inverse maps x onto 3x minus 2. Okay, so make sure that you rewrite it. You can rewrite this as f inverse of x equals 3x minus 2. You can also write that. But make sure that you are noting that, hey, this is the inverse. I'm done. That's my answer. Okay. Let's do one more example just to make sure that we understand how to find an inverse. So if we are given an inverse that maps, so this is x that maps 5, x onto 5 minus 2x. Find f. Well, remember, these are a matched pair, so you can just go back and forth as many times as you want. You're going to get the same thing. It doesn't matter. If you're going inverse to f or f to inverse, what you're doing is you're switching the x and y's, then solving for y. Okay? So let's rewrite this. This is telling us that our inverse is 5 minus 2x. So remember, this is the y. So y's change to x. and x's change to y. And remember, I want to solve for y. Okay, so first I want to subtract the 5. So I have x minus 5 equals negative 2y. Now the y and the negative 2 are multiplied, so I want to divide both sides. So you can write this as y equals x minus 5 over negative 2. Or if you don't like that negative 2 on the bottom, if you change the signs of everything in the equation, you've done something that's equivalent. So we can also write this as 5. So 5 became positive, x became negative, 2 became positive. All three of the things in this equation changed sign. So you can also write it like that if you like that format better, but these are the same exact thing. It does not matter. So they asked us to find f of x, so we just want to make sure that we're clear that f of x equals, and then choose one of these, whichever one you like better. It does not matter. Okay, 5 minus x over 2. So all you're doing to find an inverse is you switch x and y, and then you solve for y. And then make sure that you indicate your answer. And that's all you do.